all of you to Animats. If you have been following me all this time, you'll be knowing that till now we have finished with part 1 and part 2, the first two parts of polynomials. This is the third video in polynomials where we have taken up remainder theorem. Okay, so there will be another video where we shall be doing polynomials factor theorem. Okay, so polynomial gets done in total 4 parts. Okay, as I have already told you, please watch the video sequentially to get a better idea of it. If you watch the video completely, you will be noticing something that I have taken up every possible question in the chapter. Anything that can come in your exam, from the 2 markers to the 4 markers, everything has been covered in detail with examples. So go through the video, and now let us see what is remainder theorem. Okay, so in remainder theorem, supposing you have a polynomial which is fx, and fx, let's say, is equal to 2 x cube minus 3x square plus 5, something like this. This is a polynomial. Okay, now in remainder theorem they say that if I am dividing this polynomial with a x minus 2, now this is also an expression, this is also another expression. This expression is being divided by this expression. Okay, then they are saying that if I am dividing this expression with this, in that case, if I want to find the remainder of this division, all I have to do is equate this expression to 0. They will give us only till here. We'll have to equate it to 0 and find the value of x, which is a 2 in this case. Okay, we find the value of x, which is a 2 in this case, and then we are going to substitute this 2 everywhere in this. So basically we find f2, okay, which is 2 into 2 cube. 2 cube minus this is 3 into 2 square plus 5, that gives 8 into 2, 16, minus this is 12 plus 5, which is a 21 minus 12, and that is how much? That's a 9. Okay, so f2 comes out to be a 9. Now they want to tell us that the remainder when this expression is divided by this expression is nothing but a 9. Okay, I repeat, I have to equate the divisor to 0, I have to find the value of x, and all I have to do is I have to substitute this value of x in here. I have to substitute the value of x everywhere here, and whatever value comes, that is my remainder of this division. That is what remainder theorem says. Now I have told you the method straight away, but where do I get it from? This actually has been proved. Okay, there's a theorem which has proved this, and then we are only using the result of the proof in our sums. Now I am not giving you the proof, I am not teaching you the proof because it is not there in your syllabus. So we shall only be taking up sums of remainder theorem today. So let us do the sum. You can see here over there in that pink box, you can see the sum. So fx is equal to x to the power 4 plus 2x cube minus 3x square, okay, plus x minus 1, plus x and a minus 1 is divided by x minus 2. So they have given us this is being divided by this, find the remainder. As you can see, that question is saying. Okay, so what we do, the very first thing we do is equate it to 0. Then we find the value of x, which is a 2. Now we are going to place it over here. f2, we are going to find 2 to the power 4 plus 2 into 2 cube minus 3 into 2 square. Okay, that's a 2 square plus 2 minus 1. So wherever there was an x, I have substituted a 2 over there and written down the same equation. So that gives me 2 to the power 4 is a 16 plus, this is a 16 again, minus 3 into 4, that's a 12, and plus 2 minus 1. Now be very careful over here. Remember, for this 16, this is the sign. So I am going to use BODMAS here very clearly. I'll take all the positives together first. So this is 16 plus 2 minus 12 minus 1, and that gives me 32, 34 minus 13. Okay, and that gives me 21. So the remainder is a 21. Okay, remainder of this sum is a 21. Now let us take up the next question. You can see the sum over there. Find the remainder when the polynomial is divided by, now you will see in this sum, we'll get a fractional value of x. Okay, the next question is fx is given as 4x cube minus 12x square, okay, 12x square plus 14x minus 3, and this is being divided by 2x minus 1. So 2x minus 1 is the divisor. So what we do, we equate it to 0, x becomes a half. Now we are going to substitute that, okay. So f half, basically we are finding f half, isn't it? So what we write then? We have to be very careful, this time it's a fraction. So it is a 4 into half and a cube minus 12 into half and a square plus 14 into half minus 3. This is our sum. Okay, let us now work 4 into 1 by 8 minus, this is 12 into 1 by 4 plus 14 into half minus 3. Okay, that gives us, we'll reduce them all, and we get half minus 3 plus 7 minus 3. Okay, now how much is that? That gives us a half minus 3 plus 7 minus 3. I'll take this and this first, and I'll make it minus 6. And this is a 7 and half, which is a, so from 7 and half, okay, I'll not even add it, I'll just write it as a 7 and half. From 7 and half, if you take out a 6, you are left with a 1 and half, isn't it? So straight my answer becomes 1 and half. That's it. So my remainder for this sum, the remainder for this sum is 3 by 2. Okay, that is my answer. This is what they had asked for. Now this question you will see is slightly different. Okay, there's the way they have written, as you can read over there. Okay, the expression is given and they are saying check whether the polynomial is a multiple of 2x plus 1. Now the polynomial is px is equal to 4x cube plus 4x square plus 4x square minus x minus 1. This is the polynomial, and they are saying is this polynomial a multiple of 2x plus 1. Now this is where you have to start understanding the concept. Now when they twist the question like this, now you feel that this is not fitting into any of your remainder factor theorem. They didn't ask you to find the remainder. Okay, so what do? They have never asked you to find the remainder. So what to do? Now you don't know what to do. What are they asking for? They are asking you to check whether this is a multiple of this. Now let me give you a very small example for this. But this time when I give the example, I'm not going to give it in terms of algebra. I'll give you regular numbers. Okay, one simple sum I'm going to give you is 35 a factor of, a multiple of, not a factor, a multiple of 5. Okay, if they ask you this question, is 35 a multiple of 5? What do? You divide 35 with a 5, Okay, you divide 35 with a 5 and you get an answer which is a 7, and the remainder is definitely a 0. Yes, so when the remainder is 0, 35 is divided by 5 and the remainder comes to a 0, then you know, yes, 5 is a multiple. Supposing I would have told, is 3 a multiple, and you carry on the division, and then what do you get? Is 3 a multiple? Then you get 11, you get a remainder of 2. So 35 is definitely not a multiple of 3. Yes, so 35 is not a multiple of 3 in this case because we have got a remainder. But as long as we get a remainder 0, that means the number, this number or the big expression is a multiple of the other one. Okay. If this is a multiple, this will not leave any remainder on division. That is what I am trying to explain. So I have explained it to you in a non-algebraic way so that it's easier for you to understand the algebraic way. So this is in place of 35, this is in place of the 5. And I am trying to prove that yes, this is a multiple of this. In that case, what I will have to do is, I'll have to show that when I divide this by this, the remainder is a 0. Okay, so let me try to prove that now. So x is equal to, so if I equate this to 0, I'll get x is equal to minus half. Okay, now I'll have to find p minus half. I'm trying to work out p minus half with the intention of trying to I just want to check whether the remainder comes to a 0 or not. If the remainder comes to a 0, yes, this is a multiple of this. So let me work this out. I'll have to be very careful. There's a fraction, that to a negative fraction, and then there are powers. Okay, so each one I'll have to do very carefully. See, this minus, I have copied another minus from the value of x, minus 1. Okay, so these are the places you tend to go wrong. You write one minus and you leave out this minus. This minus is coming from the sum, this minus is from the value of x. Now what? 4 into, okay, this is minus 1 by 8 because it's an odd number, plus 4 into 1 by 4, even number, the minus vanishes, plus half and a minus 1, that is, cancel this out, okay, do not mix up this with this, follow BODMAS strictly, multiplication first then addition. So minus half plus 1 plus half minus 1. Now you see, okay, so clearly the answer is 0. Don't start adding, subtracting, multiplying, dividing, nothing. You don't need anything. If you're doing your sum correct, it is less calculations, remember. So here, this is 0. Okay, so you have got your answer as a 0. That means the remainder has come to a 0. If the remainder is 0, write clearly for the teacher to see, yes, remainder is a 0. Therefore, px is a multiple of 2x plus 1, clearly, because when we divided this by this, we didn't get a remainder, hence this must be a multiple. Now you can read the question on the board. Okay, you can clearly read the question on the board, and it is saying if the polynomials 2x cube plus ax square plus 3x minus 5, and there's another polynomial which says x to the power 3 plus x square minus 2x plus a. Remember, both of them have a constant a. Okay, the variable is x here, but the constant is a here. Leave the same remainder when divided by x minus 2. Then find the value of a. Also find the remainder in each case. Now there's a big problem. Okay, how do you have two polynomials and the divisor is same, and then not only the divisor is same, they are leaving the same remainder. Okay, so we'll name one of them as a fx and one of them as a gx. Okay, so one of the polynomials, let it be an fx. Okay, and that is 2x cube plus ax square, 2x cube plus ax square plus 3x minus 5. That is one of them. The other one, let me name it a gx. They haven't named, but you can always use your own variables and name them. X cube plus x square, okay, and minus 2x plus a, minus 2x plus a. Now when you see this, you have to note that the entire thing is in x, definitely x, that is why you have the x here. But then you have to note these are the two constants. It's not a 9, it's an a, okay. These are the two constants. Now they are saying find the value of a and also find the remainder in each case. Now let us start with the first part. Now what is dividing them? X minus 2 is dividing them. So if I equate it to 0, x is equal to 0. Now I shall first make, because I am finding the remainder when this divides this. So f2, that is 2 into 2 cube plus a remains as a and a 2 square. This dot is for multiplication, plus 3 into 2, okay. It's not 3.2, okay. If it confuses you, you can put a bracket here, minus 5. So that gives me, this is 16 plus 4a plus 6 minus 5, and now if I further simplify this, 22 minus 5 plus 4a, okay, 22 minus 5 is a 17 plus 4a. Now don't worry, the remainder has come in terms of a. It is supposed to come because you never knew the value of a. So it's going to come in this structure only. Okay. Then come to f. This is 2 and then you have f. Sorry, you'll have g. This time it's a g, not an f anymore. We are finding this g2. That is 2 cube plus 2 square minus 2 into 2 plus a. That is 8 plus 4 minus 4 plus a. Yeah. This is, cut this out, okay. It cancels out and your remainder in this case is an 8 plus a. Again, this has also come in terms of a. It will come because a is the constant. Now they have told, as you can see in the question, they have told that the remainders are equal. They give the same remainder. So why not equate the two remainders? We will equate the two. Okay, if we equate the two remainders, we get a 3a. This is a simple linear equation. Okay, and that gives me minus 9, okay, and a is equal to minus 3, okay. So a becomes a minus 3. So they had asked us to find the value of a. Now they had already told, as you can see in the question, they are saying they give the same remainders. So even if they say find the remainders in each case, actually the remainder is going to be the same, okay. So if the remainder in each case is the remainder is 8 plus a, because they are finally equal. So if you just find it once, good enough, okay. So all you have to do is the remainder in each case is equal to 8 plus a. This works for both the polynomials, okay. That is 8, this is a minus 3, that's a 5. So 5 was the remainder in each case, okay. Now the next question says, as you can see, fx is given as one big polynomial, and then it is divided by two different things. Just now we had two polynomials divided by one single expression. Now we have one expression and being divided by two different things. Another difference in this sum is it has two constants, okay. Leaves the remainder 5 and 19. Also there are two remainders now because there are two divisors, okay. So if the same number, supposing the number 35 only, you are dividing by sometimes 5 and once you are dividing with 3 and then you are dividing with 2, okay, and naturally the remainders are going to change. So once you are dividing with x plus 1 and then you are dividing with x minus 1, so the expression, let me write it, fx is equal to x to the power 4 minus 2x cube plus 3x square minus ax plus b. Okay, and then the other one you have, it is divided by x minus 1. Once you divide it with x minus 1 and then you divide it with the x plus 1. These are the two divisors clearly, as you can see in the question. And the remainders are 5 and 19 respectively. Please don't mix up the remainders. Okay, find the values of a and b. Okay, and find the remainder when fx is, that is a different question. We'll take up that later part of the question later. Now here we can see one thing, one expression, two divisors, two different remainders. As you know, if you have the number 35 and once we are dividing it by 2 and once we are dividing it by 3, in both the cases, if there are two remainders, the remainders are supposed to be different. You can't have the same remainders. So these are the two remainders. Now another thing that is to be noted in this question is there are two constants here, and it is the value of these constants that they are asking for. Okay, so here first I will equate this to 0 and I shall also equate this to 0. So here x is equal to 1, right? So x comes to a 1. F1 is equal to, okay, F1 is equal to 1 to the power 4, okay, minus 2 1 cube plus 3 1 square and minus a and a 1 plus b, okay, which is equal to, this is 1 minus 2 plus 3, because 1 cube or 1 to the power 4 or 1 to the power square, everything is nothing but a 1. So now if I simplify it further, I get a 4 minus 2, right? I get a 4 minus 2, which is a 2 minus a plus b. This is my final remainder when I divide this expression with this. Now I shall be substituting f minus 1 because I want to find the next one. And one more thing, when I divided this by this, they told the remainder is 5. So why not write a 5 here? Okay, I can simplify it a little more. I can make it a minus b is equal to, if I take the a that side and the b also that side, then it comes to a minus 3. Okay, now f minus 1, what is that now? If I substitute here minus 1 cube, I'll get a, okay, minus 1 to the power 4 minus 2 minus 1, this is cube, plus 3 minus 1 square minus a minus 1 plus b. Okay, everywhere wherever there was an x, I have put a minus 1, and that is giving me 1 minus, this gives me a minus 1, so 1 plus 2, this is a plus 3, okay, minus, and there's a plus a plus b, and this is going to be equal to a 19. Okay, so a plus b is going to be equal to, here I have a 6, so a plus b is a 13, right? A plus b, if you subtract this 6, it is a 13. Okay, so a minus b is equal to a minus 3 and a plus b is equal to a 13. Simple addition of two equations, 2a is equal to 10, a is equal to 5. Yep. If a is equal to 5, I can substitute it here if I want to. So I'll substitute 5 plus b is equal to 13, b is equal to and 8 clearly. So I have got the values of a and b, b is equal to 8. Okay, so these are my two answers. Now there is a second part of the question, hence find the remainder when fx is divided by x minus 2. Find the remainder when fx is divided by x minus 2. Now what do they expect you to do? They expect you to substitute the values of a and b in this, okay, in fx. First form fx properly. So what you have to do, x to the power 4, yeah, minus 2x cube and then plus 3x square and then you are going to put the value of a, which is a 5. So it is minus 5x. Yes, after you have taken minus 5x plus 8, okay, minus 5x plus 8, and this one when it is being divided, okay, this one fx is this, and this one when it is being divided by the given expression is x minus 2. So I will x minus 2 is equal to 0, x is equal to 2. So all I have to do is find f2, which is going to give me the value of the remainder. So 2 to the power 4 minus 2, 2 cube plus 3, 2 square minus 5 into 2 plus 8. Okay, that gives 16 minus 16 plus 12. Yes, minus 10 plus an 8, and that gives me, please don't waste time in unnecessary calculations, that gives me a 20 minus 10. Okay, clearly it is a 20 minus 10, which is a 20 minus 10, and that gives me a 10. Okay, so this is my final answer. This is the remainder when you divide the same expression with this. Now why have they tagged along, why have they attached this question with the other part? They have attached this question with the other part. They only want you to see substituting the values of a and b and forming the polynomial correctly now. Okay. So this is what we have in remainder theorem of polynomials. Next we are going to take up factor theorem. Okay, I hope you have understood remainder theorem. If you have liked the video, do not forget to like, share and subscribe. You might have seen there are many things in this video which you are little doubtful about. So you should always go back to the previous videos. Okay, you'll find the links in the description box. You should go to those links and clarify your doubts first, because this is my third video in polynomials. Okay, there's going to be one more video in polynomials which is going to take up factor theorem. Okay, then bye all of you, keep practicing.